Hi everyone, this is Max Koo from University of Waterloo. I will be presenting our oral paper today. So what is multimodal explanations? When we are communicating abstract concepts like math or physics, we rarely rely on text alone. Humans often use visual scaffolding like figures, slides, or animations to make complex ideas intuitive. This combination of text, visuals, and narration is what we call multimodal explanation. We showed that multimodal explanation offer more explainability and interpretability. Then why multimodal explanation matters? When evaluating AI model understanding, prior benchmarks often relied on multiple choice or free-form textual answers, which can mask superficial reasoning, and many real-world concepts, like geometry, are spatial in nature. So text alone itself can hide the AI hallucinations, and the visual explanations can expose those deeper flaws from the AI model's reasoning. So this leads to our question: can AI generate multimodal explanations? We select STEM theorems as a testbed, as many STEM theorems, like geometry, they are inherently spatial, and video is a good form of multimodal media. This form a challenging task and represent TheoremExplainAgent, which is the first system designed to generate long-form video explanation for theorems. So this is our design framework. Given a theorem and its context, our model will generate a multimodal explanation, which is a video in our context. Then we're evaluating them using automated metrics in terms of measuring the visual contents, the factually accuracy, and also the logical flow. Here is how TheoremExplainAgent works. First, there will be a planner agent that breaks down the theorem into scenes and generates narrations. Then, a coding agent will turn the plan into Manim code, which is a Python library for visualization. We select Manim for this because it's often used in teaching scientific concepts, and it has a good ecosystem to support on different discipline plugins. We also support try-on error for robustness and integrate the RAG system at 3 stages to fetch the relevant samples. This led us to create videos that is 5 to 10 minutes long, which is far beyond the 20 seconds baseline that non-agentic LLM can manage. So look that we did not provide any hints about the theorem details in the context or in the RAG system, so we are testing whether the AI model actually understanding the concepts. Then to evaluate this, we create TheoremExplainBench dataset, which is a standardized benchmark with 240 theorems across math, physics, chemistry, and computer science. In each of the categories, there will be 3 difficulty levels, from high school to undergraduate to graduate level. And then we also introduce 5 scoring metrics that capture both textual and visual explanation quality. The 5 metrics are accuracy and depth, logical flow, visual relevance, element layout, and the visual consistency across scenes. Interestingly, we found that layout and visual relevance showed higher alignment with human ratings than logic-based ones. This suggests visuals are often more easier to spot for human. So for the experimental setup, we evaluate TheoremExplainAgent using the 4 models: GPT-4o, Claude 3.5 Sonnet v1, Gemini 2.0 Fresh, O3 mini medium, using for both planner agents and coding agents. Among all those 240 theorems in TheoremExplainBench, we tested whether models can write proper visualization code to generate the video. If it can generate the video, then how effective are those multimodal explanations against actual human-made Manim videos? And then we also perform case studies to show visual explanations can exploit flaws in logic and flow, which is often listed in text. So here we show the results on whether the models can generate proper videos in Manim. We found that O3 mini is the most stable agent with a 93.8% successful rate, but GPT-4o also performed reasonably well, and Gemini has struggled with complex theorems. However, an obvious pattern is that chemistry was the hardest domain after all, likely due to complex 3D structures and rendering challenges that is not properly supported in Manim. And we also spotted that with RAG, it slightly decreased the success rates in most cases because it could introduce the potential noise or distractions. Among those successfully generated videos, we employ the 5 decided metrics towards them, and we find out O3 mini and GPT-4o scored around 0.77 score, which is comparable to human-made Manim videos, and Claude scored the highest, although it only succeeded in a few samples, and human-made videos leads all other models in terms of the visual relevance and the layout. So I think another clear pattern is that the element layout is a common challenge for those AI models, which they can only achieve average 0.6. So here is the case that shows why video explanation matters. For the chain code theorem that we are trying to explain here, which is a simple image compression method, the text output looks plausible, is wrong, but it doesn't actually reveal a key mistake. But in the video, we can clearly see the arrows were pointing the wrong way. So we conducted a human study, and we found that 60% more of participants can spot the error in video, but not in the text. This shows how multimodal outputs helps debugging AI reasoning. As the increasing popularity of researchers using video models as role models, we added some video model baselines, and we find out they generate short and incoherent clips without narration or structure. They lack the reasoning and also the planning. So, but more recent model, while they may be useful for rendering the results in the future, they currently cannot replace TheoremExplainAgent. So to wrap up, we introduced the TEA, the first system for video-based theorem explanations, and then also THB, a benchmark with metrics tailored for this task. Our results show that multimodal explanations help expose reasoning flaws that text alone cannot, but challenges remain, especially in the layout control and evaluation consistency. So that's the end of our presentation. And if you want to learn more, feel free to visit our project page, and we have already made our code available on GitHub, which we have already got 1.5k stars. Thank you.